Alrighty, so for those of you that don't know, thanks again Leo for the introduction, but ValleyDAO is a DAO focused on funding synthetic biology research for climate and environmental sustainability. And if you don't know much about synthetic biology research, you'll find myself, Mark or Albert, we're always happy to chat about that. But what I'm actually here to talk about today is community-curated tech trees. And we've heard a lot about those over this weekend, and what I want to add on top of all of these conversations is how we can potentially operationalize them in DAOs and how we could use them to create the impact that we're all trying to achieve. And so just a quick introduction on myself. I have a bachelor's in microbiology from the University of Liverpool. I studied systems and synthetic biology at Imperial College, where I was fortunate enough to be funded by DeepMind actually, for a keen interest in them funding synthetic biology research. And then wanted to really break out into AI and those interfaces. But currently I'm leading product and tokenomics at ValleyDAO, although I originally joined as the communications and community lead. But underneath all of that, this is kind of like my simplification of who I am. I'm a very curious person. I'm someone who wants to learn how the world works and use this knowledge to improve it, as I'm sure many of you in this room also want to do. But the reality is quite complicated, and when I got to academia, I realized that, yeah, this isn't probably for me, and it's not the most efficient way for me to create impact by leveraging my particular skill sets. And so I became really interested in decentralized science because it promised this alternative way of doing science that seemed more fun, more community-spirited, more collaborative, and less kind of slow-moving than the traditional system. So super interested in that stuff. And I think in terms of BioDAOs, it's really important to make this differentiation between two different types of science. And so what I like to think of it as the first type of science, which is traditionally done in academic institutions, is this forager-style science, which is where there's lots of seemingly random exploration in many different directions. The velocity in this case would be zero because you're moving in every direction. But that doesn't mean that nothing's happening. It means that there's lots of exploration happening. The organization, the institution can be quite static in time. But when you discover something, of course, you then allocate more resources. You start to do more exploration and investigation in those areas. And that's not to say that this type of science is any less superior to the alternative. It's definitely an essential component of it. And I just want to make that distinction because I think what we need to focus on, or at least recognize that what we're focusing on in BioDAOs is something a little bit different. It's this goal-oriented science, where we're moving maybe parallel, maybe tangential, but moving roughly in the same direction. So this red arrow represents alignment on the ultimate direction that we want to move in. And so if we're all moving roughly in that direction, then our velocity is positive towards that goal. But something I find really interested in, and something I've been spending a lot of my time thinking about over the last few months is these technology trees and how they can carve out pathways into the future. So we already had an amazing panel with Martin and Trent and other discussions about technology trees and how you can apply them. So I'm not going to bore you with the details, but kind of how I see technology trees as being useful is the ability to map out obstacles. And then, of course, map out possible pathways to overcome those obstacles. But the interesting thing, and hence why I've drawn this ant analogy, is because ants do something really interesting, right? And if you've studied ants, or I have a personal fascination in ants, they are really like truly decentralized. There's no top-down leadership. They are able to solve complex problems just by interacting peer-to-peer, which is something we should learn a lot from in decentralized science, of course. But what ants do, they map out these obstacles, they carve out possible pathways, but they don't just do that. When they actually get there, they are consolidating those viable pathways so that when the next person comes along, or the next ant comes along, they don't have to go through this whole problem-solving process. So what happens is instead, this first ant, the forager, so yeah, in this occasion, you could think of the ant as a forager-style scientist, is working out, okay, how do I get around these obstacles? What is the possible path to reach the food? And what this red arrow represents is that consolidation. What the ant is doing is leaving a pheromone trail, and once it reaches that food source, it's going to retrace its steps back to the nest. And so that then consolidates that pheromone trail is stronger than all of the others, and you get this nice environment where you've got high signal, low noise, which I'm sure we all want more of in DAOs. And what it enables actually is then scaled deployment of resources, right? Now you don't just have one ant going to the food source, you have hundreds, thousands of ants going to the food source, and then until they eventually exhaust it. And this is really practical and useful when we're thinking about goal-oriented science, because yeah, we're trying to move in a common direction, and once we figure out a possible way or a leverage point that we can use to get there, well, we shouldn't be doing the foundational stuff anymore. We shouldn't be having to, in the case of SynBio, for example, develop our own genetic tools and start basically from scratch, because everybody's patented everything, or there's not much sharing of data, right? So you are able, as I said, to carve out these pathways and then allow the next person to come along and quickly reach their destination. And I see tech trees as being used in the same way, because if we're developing them, then what we can do is carve out pathways, bring anyone from the outside up to our most recent context, and enable them to find opportunities for them to allocate resources or apply their skills to particular parts of the pathways in order to help solve that common goal. And this doesn't just, this analogy doesn't just apply to science itself, it also applies, I think, to the tech trees as materials. So this is, as we've seen previously, the foresight tech tree. In this particular example, it's for curing diseases. But I made this analogy or comparison because I see it as this type of exactly forager-style science, right? You've got a map of all of this information, which is, of course, very useful to give context, but it's kind of like a sensor, right? Like you are sensing the environment, you're taking readings, but it's very hard for me to look at that and say, okay, this is how I'm going to solve that problem, or this is how I'm going to create impact in a particular area to overcome a bottleneck. And so what I spent a lot of time thinking about after that is how do we operationalize these tech trees? How do we make something that's a little bit more strategic that a DAO or any community of people that are looking to solve a particular problem can use to their advantage? And so this is kind of one question I had to ask to solve this problem, right? Like, what's the difference between this sensor analogy and an actual agent? Agents are able to solve problems, and the clue is in the word, right? The answer is agency, and what is agency is having a goal imprinted onto these sensing systems. So not only are we now reading and recording our environment, but we're able to use that data to guide us through to a viable pathway. And so how do we actually create a goal that will enable us to carve a pathway to a particular future? Well, you need to understand where we are now, our current world state, and then of course you need to understand where you actually want to be. So it's an A to B process. Sounds pretty obvious, but it's worth thinking about these fundamentals when you are trying to develop something useful. So this is an example of a tech tree that we produced in Paris in collaboration with, of course, the coordination editor guys, and of course it looks very nice. But what you'll see at the top, and I apologize that the writing is very small, let's see if I can zoom in. Oh no, that doesn't work. But what it says at the top is we've got this very clearly defined problem statement, and that problem statement is quantitative as much as it is qualitative, because if we want to get to a goal and we want to be very pragmatic about it, we have to be able to measure our progress. And so how we think about formulating these goals is, as I said, think about where we are now, think about where we are want to be in the future, and then formulate a problem statement that basically explains why we are not there now. And then underneath that problem statement, you start to look at what are the specific challenges, the obstacles that are stopping us from getting there. And I do have a little demo just to show you the kind of structure. Where is it? Yeah, there we go. So this is the kind of structure that we use to create this tech tree. This is actually produced in Miro because it was nice to visualize it, and we didn't actually have the capability to visualize our tech tree in Paris. But as you can see on the left-hand side, we've got these different layers, right? So what we actually include in the tech tree, it enables us to be able to look specifically at the different problems and then reach all the way down to the bottom, which is very, very specific challenges that could be addressed to solve this overarching problem. And that I call the action layer. That's where we can then tangibly create impact. And as a community decide, okay, what are those actions we want to take and how do we allocate and deploy resources to take those actions? So just to jump back a little bit to the coordination editor, well, as I said, you've already seen the kind of explanation and demo of this, so I'm not going to spend too long on it. But what it enables for me is the ability to leverage LLMs to aggregate, synthesize, and structure information. That to me is a creation mechanism, and there's reasons I've included these words specifically that will later become clear. And then it also allows you to vote on and consolidate additions. So you've got this process similar to the ants leaving pheromone trails where you can say, okay, I'm another ant, I've come on and I've validated that this pathway is viable, or I at least believe that this could be a potential solution. So you have this curation mechanism. And then you're able to also synchronize versions, right? Multiple people can be working on the same tech tree with different versions, and then, of course, fork or combine those. Or they can be working on completely different aspects of the tree that fall under the main kind of branch, and then be able to synchronize and pull in all of those versions. So suddenly we've got this ability to aggregate the intelligence, the knowledge space of thousands, hundreds of thousands of people into a single unified framework that we can then use to reference with LLMs and identify problem areas of bottlenecks that we might be able to solve for. So the question is, well, there's several questions, of course, but we have to ask ourselves this, and I think we're always asking ourselves this, like, why a DAO? Why does this make sense for a DAO? And in the case of tech trees, I think because DAOs are fundamentally goals or values aligned. I mean, that's the whole point, right? We're communities of people that believe in a certain mission and want to work together in whatever way we can to get there. But we also have pools of people with diverse skills and expertise that should be leveraged, of course. And yeah, token-based incentives, I think, is an interesting one when you start to think about incentivizing the creation of these trees, because much of the work has already been done by researchers completely for free. So this process is pretty similar to a literature review, but rather than just creating a document that like 5 people are going to read, maybe 20 people will reference, like you're creating a living representation of our current world state and how we're going to get to the future. And I think that's both more exciting, but if we're able to tokenize the incentives there, I think it will get much more interesting in terms of incentivizing those researchers to work on these problems. But we also have hierarchical governance and contributions, right? So we can structure this creation of this tree in such a way that we incentivize quality over volume. Because I think if you look at any kind of curation problem, the big question is, how do you incentivize people to create high quality, very accurate things, which is essential in science, of course, rather than just creating volume of submissions. So we want to structure it in a way where, you know, there's experts that are voting on certain branches, and that we can generally, commonly accept a truth that we're working towards. And then the other question is, what problems could this solve for DAOs? And I think this is the most interesting one, because DAOs have a lot of problems, as you can see. And this mechanism, I think, has some really interesting attributes. Because one of the biggest problems I think we all face in DAOs is onboarding researchers and contributors, not only onboarding them, but keeping them there, right? Which is fine in the case of if you've got lots of activity, lots of very practical examples of things that they can get involved in. But when you're looking at, let's say, deal flow applications, well, we don't always have thousands of applications to go through. So how do we keep people there? How do we keep them engaged? How do we have them working on something where you know, it's a linear pathway? There is a constant flow of information and creation, and there is kind of no end to this task. It's being constantly updated as we go through time. It can also help us achieve focus. I think it's another major problem in DAOs. We're all talking all at once and often in those different directions, so looking more like the foragers than the goal-oriented communities. Thesis building, I think this was one of the first examples that we kind of thought about using these technology trees, is how do we apply them to actually help us create our thesis when we're investing in different synthetic biology research projects. In order to make a good investment, you obviously have to understand the landscape, and I think any investor worth their money will tell you that that is a long and laborious process. But suddenly we've got this tool that we can then share not only with our community, but share with potential investors, grant funders, etc., to be able to look at and say, okay, we can use this information that has been curated by scientists in order to help us get to the right decisions. We can also use them to source deal flow and stay ahead of the curve, which I think is really, really important as well, because not only are we mapping out all of what's happening, well, I mean, if we are mapping out all of what's happening at any given time, then we're able to look at when projects make sense for us as a community to invest in. And as I said, share that with other people who might be entering at slightly earlier or later stages. We are also creating a knowledge bank, of course, that other people can use. So not just the investors and people that want to deploy resources on top of that, but we're creating a knowledge bank that anyone can use, like people, students, researchers, to bring themselves up to speed on what's happening in the space. I think IP NFT visibility and utility could be interesting here as well. I don't want to spend too much time on that, but because I'm conscious of time, but I think it will be definitely worth a conversation, especially with the BioDAOs and Molecule folks, to see how this could be leveraged. And then the final one that I just want to highlight here is leveraging developers, which we don't have a ton of applications for in BioDAOs. It's very science focused, but we do have a ton of really smart and intelligent and capable people that are more focused on the internet and technology tools that we could develop. And I think creating this information layer, this resource, allows some interesting things that I'll highlight in just a moment. But this is just to say the ingredients that you use when you're creating these tech trees determine the recipes you can cook. So this, I'm quoting Martin here because he always talks about ingredients. And so these are some of the ingredients that we looked at, including in our tech trees. So of course, papers, but also summaries of those papers and specific communications, maybe articles and stuff like those. Authors and researchers linking those people to those papers and creating profiles for them. Of course, funders enabling them to view and have visibility on what's happening in the landscape, but also be able to directly reach out to people that they find interesting and want to support. TRLs, this is a major one, actually, I find super exciting, is we can start to map out what is the maturity of technologies and how can we as communities decide to deploy resources at the right time in order to create the impact and overcome bottlenecks in specific areas. Then impact and scale metrics, so actually looking at when we deploy resources, what are the outcomes, how are we creating impact with those, and then using those as a closed kind of feedback loop to say, okay, how do we make better decisions to create more impact and scale? Patents and IP, of course, that would be nice to have that all in one place. I know there's lots of libraries out there, but having this linked to lots of scientific context would be super interesting. And then just question to like pop into people's brains is hypercerts, NFTs, and tokens. Those kinds of things could be interesting to include as well, especially in the case of DeSci. So what problems can DAOs solve using this? Well, these are some of the examples that I think that we could address. Funding, for example, as I've already talked about, but also market analysis, prior art search, understanding what's happening in the landscape and where we can create impact, of course. Overcoming those scientific bottlenecks I've already talked about, science communication, and then there's global coordination of resources and lobbying. So if we are able to onboard lots and lots of researchers from a diversity of institutions and organizations to this process, then what we've created is kind of like a consensus of what we should be doing. And I think that's super interesting to bring that to politicians and people that can create that larger scale impact to say like, oh, hey, we've got a plan, so give us 10 million and this is how we're going to deploy it. And I think they'd appreciate that too, of course. Literature reviews, as I said, this process already kind of resembles that process, but it's creating something that I think is much more meaningful and useful than an individual literature review. And then collaborations and partnerships, how can we link people up that are working in relevant fields to be able to help each other out and do things that might be analogous but might not be obvious why they should work together. And I think that's something that the LLMs can really help us do, as Martin said yesterday. They're really capable at being able to take disparate pieces of information and find relationships between those. And then ecosystem development for industry niches. So actually seeing, like building communities for these very small, small scientific niches. For example, like microalgae research, where there's not a ton of people doing the stuff, and people are finding that they have to develop everything in-house. Of course, they would want to be connected with other people in their industry if they're able to see them and help each other out. So how do we actually get there? Well, this is kind of like where I see a massive analogy towards blockchain. So this creation and curation mechanism is what I see as the layer one. We are creating this information layer that we can then reference and use and create applications that rearrange the information and synthesize it in ways that are interesting and useful. And I've included a few examples here. Some of them I've already talked about, but obviously a big question mark. And I think the important thing to note here is that we, as a community, couldn't possibly develop all of these applications ourselves, but that's the beauty of blockchains, right? They've been creating these layer ones, and then people are building applications and utility on top of them. So what I find really interesting for our community is being able to build this layer one, but then also empowering individuals, groups, especially of developers, as I mentioned earlier, to be able to create these applications that do have that utility to solve problems, real problems in science. And then layer 0, question mark here, but I think this is also an interesting concept that came up very recently, is looking at scientific data, metrics, and variables, which could be imported as oracles from other sources. So, of course, we can't always agree on data and things that we want to work towards, but being able to import those things as composable and swappable metrics would be interesting, because then you can change your frame of reference. The target moves with you, especially through time as things change as well. And this is just our roadmap. I won't go too much into that because I know we're hot on time. But if anyone finds anything interesting that I've just talked about, then you can scan this QR code, which will take you to our Discord. And of course, we're always happy to chat about this. And then you'll find my social links on that side there. Thank you, everybody.
Thank you very much, Morgan. We have room for one question, and I see it popping up right there.
How do you hope to get that mainstream? I mean, you're going to have early adopters like crypto-friendly, but most scientists don't even know what the DAO is, and they don't have a MetaMask, and so there's a lot of barrier to entry for them. How do we get that kind of stuff to be the daily? Because if you don't do mass, you're just basically niche and super cool to come at the conference, have the lunch, and then go home. But like, what is your strategy to that every scientist that wakes up thinks about their DAO, their like decentralized whatever, beta whatever? How do we do that?
Yeah, no, it's a great question, and I think it relates to what we heard from the previous talk, which is like you need to find this Web 2 way of onboarding them. And actually, what I find most exciting about the tool that the Lateral guys have developed is it does abstract a lot of that away from the process. And I think onboarding them to this independently of the DAO and saying, well, here's this resource, here's all these applications and interesting things that you can do with what we're building here, is an obvious fit to them. They don't need to ask, okay, why a blockchain, why are we decentralizing things? This all should, in theory, make sense to them and does excite a lot of researchers because they all, at least from the conversations I've had, and believe me, I've had many, they all believe that we could be doing much better in science and working much more collaboratively than competitively. So I think onboarding them to this process as something independent of the DAO, but also having those links to say like, okay, we are a DAO, we're a community of people that are just, like we sit on this layer too. We're a funding body, and if you want to participate in that process, then of course you can. But if you're not interested in that, and you just want to use the applications as you would any other application, then giving them that capability to use it in the normal way, and abstracting all of the Web3 stuff away, I think is the way forward.